You order food, open the app, and watch a little digital car make its way through the streets to your front door. When we look at that screen, it's easy to assume the phone actually understands the neighborhood. It knows what a street is, what a house is, and how the world fits together. But computers don't have eyes. Standard databases store information in rigid rows and columns. Ask this spreadsheet if an address is inside a delivery zone, and it gets confused. Text cannot comprehend space. To navigate reality, computers translate our physical world into a geometric language called spatial data. If you peel back the map on your screen, you won't find pictures of streets. You'll find a massive system that breaks our world down into 3 highly simplified geometric shapes. The first shape is the point. A point represents one highly specific, exact location in space, like the front door of your house. A database uses these single dots to catalog millions of distinct items. A fire hydrant is a point. A specific oak tree in a park is a point. A historical monument is a point. By treating an object as a point, the system translates physical items into mathematical coordinates a computer processes in a fraction of a second. The second shape is the line. When the delivery driver leaves the restaurant, the database draws the exact route by connecting 2 points together. If you look closely, a line is really just a path created by chaining a sequential series of coordinate points to one another. Any sprawling, continuous feature on Earth is tracked this way. Rivers, highway systems, train tracks, and oil pipelines are all filed away as long, winding lines. But how does the app know if you live too far away to get food delivered? That brings us to the third shape, the polygon. A polygon is an enclosed area. It loops back on itself to create a hard, unbreakable border. Massive geographic features rely on polygons to exist digitally. Natural lakes, official city limits, and vast state borders are all drawn using these enclosed shapes. Lines dictate how we move, while polygons dictate where our borders stop. Together, they give the database a complete structural blueprint of our territories. Because these 3 shapes are stored as geometric objects instead of text, the computer can perform math directly on the geography. As you stack these geometric layers on top of one another, the computer can finally interact with the environment. It can instantly calculate the travel distance from the restaurant to you, simply by measuring the exact length of the route line. And it checks if your house is eligible for delivery by running a rapid calculation to see if your specific point falls safely inside the restaurant's polygon. Layering simple geometry transforms a static, unreadable picture into a dynamic, living environment that a machine can measure, analyze, and understand. This architecture of points, lines, and polygons is the foundation of a professional framework called Geographic Information Systems, or GIS. It's the tool ride-sharing apps use to scan a 2-mile radius and dispatch an available driver to your curb in seconds. It's the system urban city planners rely on to untangle congested grids and route emergency vehicles through traffic safely. Environmental scientists use it on a massive scale, tracking the growing boundaries of wildfires as polygons to predict which communities fall inside the danger zone. Whether tracking a massive natural disaster or a local pepperoni pizza, the underlying geometry is the same. The next time you open a digital map, you're looking at an active language of geometry that organizes the physical world for every device we own.